Monostable. The rules that we got here for this one, from the formula sheet we got the time constant is RC and the monostable pulse time is 0.7 RC. Two rules. So we've got the voltage across the capacitor can only change slowly, and the voltage across the resistor will always end up at 0 volts given enough time. So let's have a look at the circuit. Now to start with, we're going to assume that T is high. We're going to assume, because of rule 2, that the voltage across the resistor will end up 0 volts. So that's 0 volts. So we've got 0 volts going into this NAND gate with both inputs connected together. Then Q is going to be high. T is high, Q is high, X is low. And you can see that from the truth table. Now what we're going to do is we're going to make T go low for a very short time. Just pulse it low. And what's that going to do? Well, when we look at the truth table, we can see that when T goes low, it's going to cause X to go high. So X will go high. If X jumps up by 5 volts, then rule 1 says that Y will jump up by 5 volts, and then rule 2 says it will head towards 0 volts. So it jumps up and it heads down slowly. And when the input, when Y, which is the input to the NAND gate, goes high, it means that Q, which is the output, goes low. Now, when this is falling down, we're going into a logic gate, and a logic gate has got a switching threshold of 2.5 volts. So as long as this is above 2.5 volts, the output's going to be low. When that goes below 2.5 volts, the output's going to go high. And to get from 5 volts down to 2.5 volts, halfway down, that will take 0.7 RC seconds. So from 0.7 RC seconds, Y is above 2.5 volts. So what's going to happen now? Q has gone high, T is high, and this means that X goes low when we look at the truth table. And X has suddenly dropped by 5 volts, which means that Y is going to drop by 5 volts, but there's a diode on the input of the logic gate, and that clamps that down to minus 0.7 volts. Let's have a look at what happens when we put a long pulse going in. We hold T low for a long period of time. So what's going to happen then is X, as before, starts off low and it's going to go high. Y is going to jump up by 5 volts again, and it's going to head down slowly. And Q, again, will start off high and it will go low. Again, because we've got the 2.5 volt threshold, which takes 0.7 RC to go by, what we've got is Q goes low for 0.7 RC seconds. Now to work out what's happening on this one, let's go through. So as soon as that goes high, we've got a high at Q, we've got a T, T is low, which means X is going to remain high. Y, there's going to be no change at X, so Y will continue falling down towards 0 volts. Now as soon as T goes high again, this is going to cause, we've got a high and a high going into the NAND gate, so the output, which is X, is going to go low. X dropping by 5 volts will mean that Y will drop by 5 volts, but the diode on the input of the logic gate will clamp that, and then there's no change at Q. So it doesn't matter whether it's a long pulse or a short pulse, Q will always go low for 0.7 RC seconds.